This is Pre-Calculus, Section 1.5 Notes, Day 2. Yesterday we talked about linear equations and absolute value equations. Today we are going to talk about quadratic equations. Standard form for quadratic equations looks like ax squared plus bx plus c equals 0. Okay, hopefully you remember from your algebra days, we have a whole bag full of tricks, techniques for solving quadratic equations. Okay, one trick is, when possible, using square roots. Okay, now we can only use square roots to solve when there is no x term, like if we had x squared minus 12 equals 0. Okay, then we could solve using square roots. If we have an x term, then square roots isn't going to work for us. So the next trick we have is, if it's able to be factored, we can solve by factoring, followed by using the zero product property to solve. Our third method here is our quadratic formula, which hopefully you recall is x equals the opposite of b plus or minus the square root of b squared plus negative 4 times a times c, all divided by 2 times a. We are going to derive that in just a moment. And then our fourth way that we have for solving quadratic equations is completing the square. And the process for deriving the quadratic formula actually comes from completing the square. Okay, so let's take a look at that right now. We start with the standard form of a quadratic equation, ax squared plus bx plus c equals 0. Hopefully you recall that if you are completing the square, a must be 1. Well, since a is generic here and a can be anything in this equation, we're going to need to divide by a so that we ensure that we've got a 1 in front of that x squared. So our first step is going to be to divide everything by a. So that's going to give us x squared plus b over a times x plus c over a equals 0. Okay. The next step in completing the square is to get the x squared and the x terms alone on the left-hand side. So we are going to move that c over a to the other side using subtraction. So I'm going to have x squared plus b over a times x, I'm going to leave a little space, equals negative c over a. Now I'm leaving a little space for what I call the box. The box gets added to both sides because this is an equation. So what we do to the left-hand side, we have to do to the right-hand side. And what goes in the box is always your b term divided by 2 and squared. Well, in this case, our b term is actually b over a, right? So it's going to be, so our box specifically is going to be b over 2a squared, which when we follow our exponent rules and we sprinkle that exponent, we end up with b squared over 4a squared. So b squared over 4a squared is what is going to go in our box on both sides. Okay. On the left-hand side, we would like to factor that. The whole idea of completing the square is that whatever you add to both sides of the equations creates a perfect square trinomial on the left-hand side. So this can now be factored into the same binomial times itself, and it's going to be x plus b over 2 times a squared. On the right-hand side, I'd like to add these two rational expressions together, so I'm going to need a common denominator. Since my first denominator is a and my second denominator is 4a squared is going to be my common denominator. So this numerator is going to stay b squared, But to change a to 4a squared, I need to multiply that negative c times 4a. So this becomes our negative 4ac. Now I can go ahead and I can rewrite my right-hand side as one fraction. B squared plus negative 4ac. Hopefully this is starting to look a little familiar to you. Over here I still have my x plus b over 2a squared. So now the next step, if I'm trying to get x alone, because that's our goal, is going to be to undo the squared. So I'm going to go ahead and I'm going to square root both sides of this equation. I'm going to square root all this, and I'm going to square root all that. The square root and the squared cancel. So over here I just have x plus b over 2a equals. Now over here, whenever you square root, first of all, remember you get two answers. So I'm going to introduce my plus or minus there in front of the radical. And upstairs, I'm going to have the square root of b squared plus negative 4ac. That can't be simplified because it's a family. But downstairs, 4a squared is a monomial, and it happens to be a perfect square. So the square root of 4 gives me a whole number 2, and the square root of a squared gives me just a. I'm almost there. So the last thing that I have to do is I have to move this b over 2a over to the other side. So I'm going to subtract it. That's going to give me x equals negative b over 2a plus or minus the square root of b squared plus negative 4ac all over 2a. And since I have a common denominator, I can go ahead and I can write this as one expression. So I have just derived the quadratic formula. X equals the opposite of b plus or minus the square root of b squared plus negative 4 times a times c, and this entire thing is over 2 times a. Beginning with the standard form equation for a quadratic trinomial, we used completing the square to derive the quadratic formula. I want to remind you that the quadratic formula is on a black poster on the back wall of my classroom. It's always there. You will probably memorize it, but you don't have to memorize it. You just have to know how to use it. Okay, so let's use our bag of tricks to solve some quadratic equations. And we're going to use all different methods here so we can practice everything. Number one, we're going to solve by completing the square. First step in completing the square is to get your x squared and your x terms alone. So I'm going to go ahead and I'm going to move that 7 over to the other side of the equal sign. That's going to give me x squared plus 4x. I'm going to leave some space for my box equals 7. Now I'm going to add my box to both sides. And what goes in the box is my b value divided by 2 squared. So in this case, my b value is 4. 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared is 4. So what goes in my box is going to be 4. Now I have to factor this side. And it's going to factor into the same binomial times itself. Two numbers that multiply to make 4 and add to make 4. Well, that's going to be x plus 2 times x plus 2, or x plus 2 squared. And over here I have 7 plus 4 is 11. All right, now that I've completed the square, I'm going to use square roots to solve this equation. So I'm going to go ahead and square root both sides to get rid of the squared. And remember, whenever you square root, that introduces two answers. So on the left-hand side, we have x plus 2, but on the right-hand side, we have plus or minus the square root of 11. My last step to get x alone is going to be to subtract 2 from both sides. So I end up with x equals negative 2 plus or minus the square root of 11. Those are my two answers. You can leave it just like that. Question number 2, we're going to solve using the quadratic formula, but oh, caution, you can't use the quadratic formula until you set the equation equal to 0 first. Notice that my equation is not set equal to 0 yet, so I need to bring that 3 over to the other side. So I've got x squared minus 8x minus 3 equals 0. That tells me that my a value is 1, my b value is negative 8, and my c value is -3. So now I have everything I need to plug it into the quadratic formula. X equals the opposite of b. So the opposite of -8 is going to be +8. Plus or minus the square root of my b value, which is -8. I like to put in parentheses, squared, plus -4 times a, which is 1, times c, which is -3. That's all under my radical. And then this entire thing is divided by 2 times a. So 2 times 1. Okay, now I'm going to go ahead and clean this up a little bit. So I have x equals 8 plus or minus the square root of -8, quantity squared, is going to be a +64, plus -4 times 1 times -3 is a +12. And that's all over 2 times 1 is 2. Continuing to simplify, 64 plus 12 is going to be 76. Now 76 is not a perfect square, but it does have a perfect square factor. 4 goes into 76 19 times, so I can at least reduce this a little bit. I can split that 76 apart here into the square root of 4 times the square root of 19. Okay. So this is going to become 8 plus or minus the square root of 4 is 2. So 2 square roots of 19, all divided by 2. And then the last step here is I can do a little bit of reducing. Keep in mind, if you're going to reduce, you have to be able to reduce all of your whole numbers. So I have to be able to reduce the 8 and the 2 and the 2. Since they're all even, their greatest common factor is 2. I can divide all 3 of them by 2. So my final answer, 8 divided by 2 is 4, plus or minus. 2 divided by 2 is 1. So 1 square root of 19 all over 2 divided by 2 is 1. Of course, you don't have to write over 1, but I'm just going to write that to emphasize that those are my two answers, 4 plus or minus the square root of 19. Number 3, oh, this is such an easy one for factoring. Looks like we have a GCF here. We want to keep it set equal to 0 for factoring. If it's not equal to 0, then we want to set it equal to 0 first. Looks like we have a GCF of m. So if we take that out, we have m times m plus 8 equals 0. Now we're going to use the zero product property to solve. So we just say, well, we have two possible answers. We have m equals 0, or we have m plus 8 equals 0. So one answer is m equals 0. Here, if I subtract 8, my other answer is m could equal -8. Two solutions on that one. And then finally, example number 4, we're going to solve this one using square roots. That's the easiest method because we have no x term in our equation. So again, do what you see that is easy. So here, in order to use a square root, I have to first get my x squared alone. So I'm going to start by adding 3 to both sides. This gives me 8x squared equals 96. My next step is going to be to divide both sides by 8. 96 divides evenly by 8. So that gives me x squared equals 12. Now I'm ready to square root both sides. So I square root the left and I square root the right. Remember, square rooting produces two answers, so this gives us x equals plus or minus the square root of 12. 12 is not a perfect square, but I can break it apart. So I can simplify this into square root of 4 and square root of 3, and the square root of 4 is 2. So my final answer is going to be x equals plus or minus 2 square roots of 3.